The first type of question that you're going to see in this problem solving and data analysis is going to be unit conversion. And so a lot of these is just taking a rate of different units and then just converting from one unit to another. So here on something like this question, it says that they traveled 11.6 miles in 43 minutes and you want to convert to the nearest mile per hour. So what we need to do is convert out of minutes and into hours. So if we set up our expression 11.6 miles and use our labels per 43 minutes, again label the units, and now we just convert out of our unit. So we want to convert out of minutes, so we need that to be in the numerator so it cancels, and into hours, and then you just find what is that conversion. Well, 60 minutes is equivalent to 1 hour. Here your units, minutes cancel, and you're left with your answer, and if you enter that calculation, 11.6 times 60 and then divide by 43, you get your answer to be 16.2 approximately, again to the nearest tenth, and that would be your solution. You do need to know how to convert from degrees to radians or radians to degrees. Here is the conversion for that. Pi radians is equivalent to 180 degrees. And so if you start with the given information of 31 over 30 times pi radians, what we're doing is we need to cancel the unit radians. So radians will be in the denominator to cancel. Degrees will be in the numerator. And so we see that 180 degrees is equivalent to pi radians. Cancel. Here are the factors of 10 cancel. 3 goes into 18 6 times. And so you get 6 times 31 for your answer, which is 186. This final question is a little bit trickier. You can see here it's rated as hard. Okay, and in this you're given 10 million plus square yards and you want to convert this into square miles. So if we start with the original value in yards squared and we now convert out. Well, 1 mile is equivalent to 1,760 yards, so the yards will be in the denominator, so 1760, and that's equivalent to 1 mile. And so the trick to this question is that this yard only cancels with 1 of the power of 2 here, so we need another yard conversion. So what we would need to do here is square both of these. Okay, and so this winds up being 1 squared. So 1 squared miles squared, square miles, and then 1760 squared yards squared, or square yards. And so now the yards squared will cancel. Our answer will be in terms of square miles. And so we multiply this through 10,996,480, and we are dividing that by 1760 squared, and we get our answer to be 3.55, and that would be our solution. Again, make sure that you have the correct power when you're converting units. Proportions are another content area that you need to be familiar. And proportions are just two ratios or fractions set equal to each other. And so here, if we're looking to solve for x in this particular equation, what we want to do is look to isolate that variable. So if we undo the operations to leave x alone, we need to divide by 6 and multiply by y to cancel. To balance the equation, we do that to both sides. So the y's cancel and the 6's cancel. We're left with x by itself. And then just multiply across the top. 1 times y is y. 6 times 10 is 60 times b, and that would be your solution, which is option B. This next proportion, they give you the value of x over y, and you see that that value exists in the second equation. And so if you just substitute that 8 in, you get 40 over n times 8. Again, replacing x over y with 8 is equal to 8. And now if we divide both sides by 8, those cancel, leaving 1. And you get 40 over n equals 1. If you want, you can cross multiply to see that 40 is equal to n, and that would be your solution. You could also type this into your equation and write each equation separately. So x over y is equal to 8 gives you one graph, and then if you get 40 or 40x over ny is equal to 8, you get a second line. Create a slider, right? Again, we want to find the value of n, so we're testing what value of n makes these two lines equal the same thing. So we see that they get closer and closer. We still need to move beyond our limit of 10. So if we click on that and let's change this, I'll use powers of 10, move it up to 100. And as we rotate this through, the lines are going to superimpose right around here. So let's zoom in and see how close they are. So we can see it's pretty close here. Again, I'll keep zooming in. So I can see that it's off a bit as I move from 39. It's off a bit as I move to 41. So 40 is our solution. We can confirm that or solve it visually as well. So in one of the other content areas in the problem solving is going to be ratios or densities. And so if we look at ratios first, we're being asked to find the ratio of the cost of protein or cost per gram of protein. So if we say cost over gram of protein, this is the ratio we're looking for, and we're comparing an egg to a cup of milk. So if we look at egg versus milk here, we just take what the graph or what the chart gives us. So for an egg, the cost is 18 cents per every 6 grams of protein, and for a cup of milk, the cost is 16 cents per every 8 grams. And so if we simplify what we have right here, we have 3 cents per gram of protein, and for the milk we have 2 cents per gram, and so there is our ratio of 3 to 2, and that is what we are looking for. Density is related to ratios in that it is, for density, it's mass per volume. Okay, so kilograms per cubic unit is a density. It could also be a population density where it's an area divided by the total population. Okay, and you are kind of expected to know that. There are going to be, or there have been questions designed with population density in mind. So here, if you have this problem where you're told that density, and you want to find what's the edge of this, the edge length of each side of a cube, and you want to find what the total mass is. So if you think of this as density is equal to mass over volume, and then plug in what you have. So the density is given as 609, the mass is our unknown, and the volume is the volume of a cube, and so you do need to know this. It is in the reference section. If you don't know, you can pull up the reference page, and a cube's volume is the side length cubed. And so if we put our volume down here, it's just the length of each side, which is 0.9 cubed. And so here is your equation. It's now just a matter of solving this. And so if you multiply both sides by 0.9 cubed, there is your mass. And so the calculation being 0.9 cubed times 609. And that gives you your answer of approximately 444. Again, it's asking you to round to the nearest whole number. The first thing that you need to be able to do with percentages is to just understand how they're formed and what they mean. So think about the word percent means per divided by cent 100. So 7% can be expressed as 7 over 100 or just 0.07. When you're calculating just a percentage of values, it's a little bit like a probability where you're going to take the desired count over all possible values in the set. And so when you're looking at a problem like this, if you have 500,000 beads and 439,000 are silver, and you want to find the percent silver, what you'll take is the desired count, which is 439,000 are silver, out of the total possible, which is 500,000. Here, these factors of 10 I'm going to cancel, and so my calculation is just 439 divided by 500, and that gives me 0.878, which as a percent is 87.8%. And so our approximate value here would be 87%. If we convert words and symbols into calculations, we can just translate this sentence and then solve for P. So it says 5 translates into equals P percent. So again, when you look at this, P percent per 100 of translates into multiplying 25. And so when you work through and solve this equation now, it's pretty easy to solve it by hand. 25 goes into 100, leaving 4. If we multiply both sides by 4, we solve for our P value, 5 times 4, which is 20, and that would be your answer. So notice in this case, 20 as a percent is 20%. If it were a decimal, it would be 0.2, but notice it's asking as a percent. So we are going to use the 20 and not the decimal form of this. The other thing you need to be able to do with percentages is stack them. So if you're increasing or decreasing by certain percentages, you wind up multiplying those percentages together. So if you have a coupon for 20% off at a sale for 40% off, you don't just add them together. When you stack them, you multiply them. So you would take 0.4 or you would take the decimal form of those. You also will tend to work with the remaining percentages rather than the percent off if that's the form that you're looking at. So let's take a look here at this first, or these two questions kind of indicate those. So first, if you have 30% of the items are red, so that means we multiply the number of items by 0.3. And then of those, 20% also have stripes. And so again, when we stack these, we're going to multiply the 20%, and you want to find which ones meet both criteria, are both red and with a stripe. And so when you multiply these through 0.3 times 0.2, if you need to use a calculator to verify how the decimals play out on this, you get 0.06. And so 0.06 converts into 6%. And so that would be our solution. In the second example, what we're doing here is sort of stacking these percentages by working with what remains. And so here it says that a number A, or translate the equation, or So in this second case, we're going to translate the statements into equations and then solve the result. If we know that number A translates into equals 120% greater than. 120% greater than means that we're taking 120% as a decimal times whatever that value is, and this is going to be times B. Now, the second equation tells us that the number B translates into equal 70% less than 56. So work with the remaining percent. So if you're taking 70% less, that means that the remaining percent is 30%. So we're going to take 30% of whatever this next value is, which is 56. And so that's what we know the value of B is this number. And so if we plug that in right here, we'll get our solution. So A is really 1.2 times 0.3 times 56. And if we calculate that, we'll get our answer, 1.2 times 0.3 times 56. And so our answer is 20.16. Probability is a bit like percentage. It's calculated as the number of successful outcomes versus all possible outcomes. And so when you're looking at probabilities, if you take the specific value that you're being asked to find. So here it says, what's the probability that a car will be a hybrid car priced at no more than $25,000? So the first thing is to find your desired outcome. So the hybrid cars are in this row. No more than 25,000 are this column, and so we look at the overlapping number, which is 6 of them possible. And then the next thing is to make sure that your total possible outcomes are what you're looking for. So sometimes it'll be given in a specific category, and sometimes it'll be all of them. So this one specifically says if one of the cars listed for sale. Okay, so notice it doesn't say if one of the hybrid cars or if one of the non-hybrid cars is listed. Okay, so if it says any of them, that's total. So the total number of cars is 16. And so this gives you your probability calculation. And so if we, looks like we can leave it as a fraction but just reduce. 2 goes into 6 3 times. 2 goes into 16 8 times. So 3 over 8 is that probability. Now remember, probability is a value from 0 to 1. And so 3 over 8 is a probability of 0.375. And probability translates pretty much exactly to percentage. So there's a 37.5% chance that a hybrid car will be priced at, or that a randomly picked car will be a hybrid car priced at no more than 25,000. Okay, so the second, next example here says that there's a total of 350 attendees, and there's a probability for each group of these. So if we look at these probabilities here, we have a 0.24 or 24% chance that the attendee is assigned to group A. We have a 28% chance or 0.28 probability of group B, and how many are going to be assigned to C. Well, if we want to find what the percent or probability is of landing in C, we know that the probability of all of these combined is 100%, or a value of 1. So the first thing would be to combine these and calculate. So if we took 1 and subtracted the given probabilities, 0.24 and 0.28, what we see is that P would have to equal 0.48. So that means there's a 48% chance of landing in that in group C. And if there's a total of 350 people, then we can use the percentage. If 48% of those 350 will be in C, we can calculate that amount, 0.48 times 350, and we see that the answer is going to be 168. So when you're dealing with scatter plots, what you want to do is you want to make some estimates or interpretations of the graph. So a couple things that we see here. We see that a vertex exists at 2:15 approximately. We see that a y-intercept occurs at 0:17 approximately. Right? And then we also want to scan the answer choices. If you scan the answer choices and look for the differences and similarities, so we don't need to worry about the coefficient in front, but we do see that every single y-intercept is completely different. And so this makes it pretty easy because we know our y-intercept needs to be 17 or somewhere close to that. And so the only option that has a y-intercept of 17 is this one right here. Now, if it's not this clear that what your difference is, so if there's a couple different equations that have the same y-intercept based on this, what you could also do with Desmos is you could quickly set up a table. So add the plus, go into table, plot a few of the points. So we have 215, we see that that's our vertex, we'll include that. Another point that we can see here is 417. So if we type 417, and then we also see that 017 is a point. Once you get 3 points, remember you need one more order pair or set of order pairs as the power of your equation, which we see as a second degree or quadratic equation. And once you do this, we can set up our regression, label it y1 is similar to, and we can put the form that we want. We see that this is that general form, a x1 squared plus b x1 plus c. Make sure you put your subscripts, and what you see here is that your a value is 1/2, your b value -2, your c value 17, and that would allow you to confirm specifically that if you have multiple options that have the same y-intercept, where that's not the distinguishing mark. In the next scatter plot, this is a linear form, and so when you're looking at this, it asks you to find what's closest to the difference between the y-coordinate of the data point when x is 1. So when x is 1, here is the data point. That's approximately 112, and the predicted value at x equals 1. So the predicted value is this line right here, where you have the point 111. And so you're taking the difference between their y values, 12 minus 11. This is just a visual solution, and you solve it by looking at that difference. So one of the biggest advantages of using this Desmos calculator is it has these central tendency concepts kind of built into them. It has mean, it has median. Okay? And so when you're looking at these statistical measurements in this drop-down, or in the keyboard, and under functions you see here, these are all of the statistical values that you can calculate by taking a set of numbers. Okay, so we'll come back to that here in a moment, but for this first problem is a very challenging question. Okay, and it says that you have this data set that consists of 10 positive integers that are less than 53. This gives 9 of them. There's one more. I'm going to call it lowercase a. And now I have a total of 10. And it says that the mean of the 9 integers is 37, which is already calculated. We don't need to worry about it. It's just stating a fact for that. And it says if the mean of data set A is going to be an integer, which is key to this question, that's greater than 37, then what value, what's the largest value integer from this data set? So we need to find out what A is. The easiest way or best way to find that is to you can either use lists or set up tables. I'm just going to set up a table and use column X or X1 to list all of these values in my entire data set. So if I just enter each of these values here, and notice I am going to enter a value for A. Anytime you use a variable, you do need to plug in a value for it to create a slider. And so what we're going to do for this question is we're going to use our slider to see the mean of all of these needs to be an integer that's more than 37. So if I go into my keyboard under functions, what I see is mean is one of my commands. And you can also just directly type that if you have access to your keyboard. And the column, the set of data that I'm using is column X1. So as I type X1 in here, I see what my mean is. And I just start scrolling until I need that to be an integer greater than 37. So I need this to be 38. So I do need to change my upper limit. So I'm going to click on it and I'll just give it, again, I tend to go powers of 10 to give me room. And so I'm going to keep moving. I see at this point right here, my value is 37, my overall mean. And so I need to keep it extending it until that mean gets to 38. And I see here's the point where it's 38, and that reveals that the answer for A has to be 47. And there is a mathematical way to solve this as well. It's relatively complicated, and this, using the slider and a table, is very easy compared to that. Okay, in this next set, again, it gives us a list of numbers, and we want to find the mean. Easiest thing to do is to enter it either as a list or a table. I prefer using tables. So 9, 3, 5, 13, 5, 13, 12, 13, 5, 2. I put my whole list in here, and then in my next line, I can access the mean command inside the keyboard under functions. Scroll down, and I see my mean is one of the commands, and I just name this column, which is x1, and when I type x1, it gives me the corresponding mean or average, and I see that that answer would be 8. So this box and whisker plot is something that isn't really emphasized here that much, and there's two general rules that come about, or two general question content areas that come about involving this box and whisker. The first would be this vertical line. That vertical line represents the median, so knowing that is going to help you answer these questions. The other type of question I've seen with total median is going to deal with range of numbers. And so if you look at the range, which are cut off by the ends of these whiskers, here and here, or here and here, and that's going to give you the total range of values. So when you look at these questions, it's asking you, based on what you see above, which of the following statements is true? So here we're looking, median of group 1 is greater. Well, I see that the median here is about 25, 26. The median here is over 30. Okay, so about 25 to 26, and here it's about 30 to 31. So the median of mass 1 is greater. That is not true. The median of mass 1 is less than the median of mass 2. Yes, we do know that that is true. Let's double check again, these understanding and interpreting types of questions. Just look at all of the answer choices to make sure you're not missing something. The mean of group 1 is greater than the median. We don't know anything about the mean. We can't. The box and whisker doesn't give us mean. It gives us median. So we don't need to worry about that. Don't need to worry about that. We can't determine what that is. And so the only one that could work is that option B. Okay, median is, we see up here that the middle value, when you put your list, rank your list in order from least to greatest. Okay, and so if there's an odd number of terms, that's just the middle term, and if there's an even number of terms, you're going to take the average of those two middle terms. Notice this set right here is given in order from least to greatest. So if we just start counting in, so cancel the outside, keep working your way in and canceling. And when you're left with the answer, which we see right here is 66. Now, if you're uncertain about that, or you want to verify it and confirm it by using Desmos, you can. If we create a list or table with all of those values, median is one of the options that it will calculate for us. Okay, or if you're given a problem where it asks you to calculate the median of this set. So type in all of your inputs, your data points, and then if you find inside this keyboard under functions and statistics, median is one of your options. Label the column number or column, which is x1, and we see and confirm that 66 is in fact the median. So on a problem like this, you could go through and you could calculate these values, but doing that would require you entering like 40 to 80 different values in your table. You don't need to do that. What you can do right here is you see from the answer choices that we're trying to compare the mean for each of these. Well, just look here in dataset A, there's more higher numbers and fewer lower numbers, and it's switched for dataset B. And so more higher numbers means that the mean or the average is going to be higher. So just from that, we know that the dataset A is going to be greater, or the mean of that. And so this is just a matter of understanding and interpreting this frequency chart. So this means that this score of 48 appears 9 times in A, but only 2 times in dataset B. In this question, it's basically asking you to interpret the standard deviation, because we see that the sample sizes are the same, the average is the same, but the standard deviation varies. The standard deviation means the average difference from each data point from the mean. So a score of 14.7 means that dataset A on average is for each data point is on average 14.7 units away or centimeters away from 179. Dataset B, the average distance from each set or each data point from the average is 17.8. That means that it's more dispersion. It's a wider range of differences. Okay? More disparity between the highest and the lowest. And so when you're interpreting these, it says, or just look at what they're asking. Group B contained the tallest participant. I'm going to work my way up from the bottom. There's nothing that says anything about each individual. The median height of Group B is larger than the median height of Group A. Once again, you don't know anything about how many fall at the small or at the shorter end and how many at the taller end. Group A data set was identical to Group B. It's not because of the standard deviation, so we know that that's not correct. Here, this median we weren't sure about. And then finally, the heights of the men in Group B had a larger spread, so that's the dispersion. B17 is larger than 14, so yes, that's the relationship that we're looking for. Statistical claims are another place that are considered difficult just because most students haven't spent a lot of time working with these or having them explained. But here we're given a margin of error for things. And so it says that the average or mean is 6.8 with a margin of error of 0.9. That means that we're taking 6.8 basically plus or minus 0.9. And so the conclusion that we can draw from this is if we took 6.8 minus 0.9, that gives us a total of 5.9. Or if we take 6.8 plus 0.9, that gives us a higher end of 7.7. And so what you can see, what you can expect is that you will likely get values that fall between this region. Now, you don't know anything specific. You just know in general this is about what the average person hiked. And so here it says it's not possible that any visitor hiked less than 5.9. You don't know that. You just know on average that would be the likely case. It's plausible that the mean distance hiked is between 5.9 and 7.7. Yes, that is very likely. So let's move on though. Again, in interpreting questions, you should check all the answers. It's likely that most visitors hiked exactly 6.8, the average. That's very unlikely. Okay, but again, you don't know. So I'll leave it as a question mark, don't know. And it's likely that all visitors hiked between 5.9 and 7. No, some could have been fewer, some could have been more, but on average, it's that would be the average mean distance for them. Okay, so that's a lot more, or this option 2 is a little more consistent than this last one. Okay, the claims made in this last example just go to indicate when you are making these claims, you can't generalize specific claims. They have to be very specific to the category of people that were taking the survey. So here, this survey was conducted from a sample of English professors at Vermont State University. So whatever the results of this survey are, they only work for English professors at Vermont. Okay? So not all professors, only English. All English professors at Vermont, yes, that makes sense. All English professors in the U.S., nope, only in Vermont State. And all professors, no, only English professors and only at Vermont State. So what we see is the only option that can work for this one is option B.